Who among you has visited the finest galleries on our planet? Who has enjoyed the masterpieces displayed there with bated breath? Right now, we will show you an exclusive image for free, one that no one has seen before. The paintings in this video surpass in beauty and significance the great works displayed in the Louvre, the Metropolitan Museum, and the Uffizi Gallery combined. So now you will see 50 shades of Jupiter before you, a palette so rich that only the universe itself can possess it. Cable, subscribe, subtitles. One day, astronomers came up with the idea to send an automatic interplanetary station to the largest object in the solar system, Jupiter. And on August 5, 2011, it happened. As part of the New Frontiers project, the Juno probe successfully set off for our gas giant to closely examine it and its surrounding moons. 5 years later, in 2016, the spacecraft entered a polar orbit, and since then, the probe has been regularly sending large data packets to Earth, which scientists are gradually decoding. That's why we don't get brand new images of Jupiter and its moons right away, but we do receive them regularly. After all, much of the data is still being processed, but the information that has been decoded proves that JunoCam has fully justified the investment. It's one of the best cameras ever installed on a probe, even though this device integrated into the design of the automated station was not initially a priority. However, now National Aeronautics and Space Administration has changed its mind and even opened up the JCM image database, allowing third-party users to artistically process the images. The results are stunning. What exactly did Juno see on Jupiter, and what secrets did it reveal to the people on Earth? She penetrated into the very essence of the giants, was a bit blinded by the bright lightning, admired the auroras, and also discovered the main secret of our giant. The only camera on the probe began filming almost from the moment it reached Jupiter's orbit, during its flyby over the giant at a speed of 208,000 kilometers per hour. Juno saw the planet's north pole. Its central cyclone is a huge ring-shaped wheel, almost 3,000 kilometers in diameter, surrounded by 8 smaller storms swirling counterclockwise. These cyclones are generally about half the size of those at the South Pole. Juno recorded the temperature over this area ranging from 83 to 13 degrees Celsius. The conditions on Jupiter, particularly the nuances of its rotation and the tremendous atmospheric pressure, prevent storms from splitting apart or merging into a single but gigantic torm. That's why we can observe amazing patterns made up of deadly gases swirling at tremendous speeds. Why does the image of Jupiter's North Pole look different in the infrared spectrum? The thing is, when the probe approached this area, it was plunged into polar night, so the cyclones couldn't be seen in sunlight right away. Juno will need to approach the massive clustered storm at least 4 more times to fully photograph all areas of the North Pole, so we can expect many more surprises. What other secrets of this huge Jovian pole has Juno revealed so far? First, it confirmed the existence of a large X-ray spot, which can only be detected in the corresponding range. It was first discovered by the Chandra spacecraft, but Juno still has to study this phenomenon in more detail and possibly understand its nature. The spacecraft also revealed to the world a spectacular event: massive polar auroras. By the way, Jupiter surprised us here as well, not with the beauty and scale of the phenomenon, but with the fact that the planet is capable of generating auroras on its own. The phenomenon occurs because of the solar wind, but on Jupiter, it's due to its rapid rotation and powerful magnetic field. What interesting moments can be highlighted? During the mission, Juno, at the end of summer 2016, Juno made its closest approach to Jupiter, just 11,000 kilometers above the upper cloud layer, which resulted in a series of stunning images. They show spirals and swirls of absolutely unimaginable colors. Thanks to this, we not only see the distant world as if with our own eyes and literally immerse ourselves in it, but we can also better understand the process of Jupiter's cloud layer formation. Amateur astronomers worked on these images, processing them thoroughly to make them more realistic and understandable. What do you think? Did they succeed? Did you know that there are real plasma jets on Jupiter, quite different from the dangerous and spectacular jets coming from magnetars? These jets are triggered by Jupiter's magnetic field, and Juno managed to photograph the effects of their influence on the giant's atmosphere. The possibility of magnetospheric plasma flows on Jupiter was described in the journal National Communication as part of a study conducted by astrophysicists from the United States of America and China. Now, these theoretical assumptions have been confirmed. The Juno probe captured several jets in its images, including N3. The automated station also captured a unique moment when certain types of clouds rose above the others, similar to thunder clouds on Earth. In addition, Juno captured jet streams in the atmosphere that shape the planet's recognizable appearance. These structures, like parallel streams, flow from west to east and from east to west, with winds blowing at speeds of several hundred miles per hour. Fortunately, hurricanes of such strength have not yet been recorded on Earth. Which feature of Jupiter's atmosphere most often sparks debate and attracts constant attention? Of course, the Great Red Spot is a global hurricane that has been observed by people on Earth for 3 centuries. Juno managed to photograph the depths of this storm from an altitude of 8,000 kilometers. No other probe has ever gotten closer to this monster. The spacecraft changed our understanding of the hurricane's location. It was previously believed to be higher than all other storms, but Juno found out that this is not the case. The storm, like a bloody whirlwind, plunges about 300 kilometers deep into Jupiter's layered gas cake. Jupiter's atmosphere is truly a paradise for hurricanes. Some of them last only a few days, while others are incredibly large and rage for centuries. Just take a look at the image taken by Juno in the summer of 2020. This is what the entire Jovian atmosphere looks like. There isn't a single island of calm in it. But without a doubt, no hurricane can truly compete with the Great Red Spot. Its sheer size alone is impressive. 3 Earth-sized planets could fit inside it. A century ago, the Great Red Spot measured 40,000 kilometers by 14,000 kilometers. But now, it has shrunk to almost half that size, though the wind speed remains the same, over 600 kilometers per hour. Are there lightning storms on Jupiter? Where else would they be if not on this giant? The atmosphere here, unlike Earth's, is not made up of water vapor clouds. Instead, it is mostly filled with gases that are deadly to humans. Ammonia clouds, located closer to the southern and northern poles of the planet, are a dangerous phenomenon on Earth as well, but they usually occur closer to the surface. The equator is cut by electrical discharges that are 10 times more powerful than those on Earth. This is how Juno saw them. The greenish tint is explained by the presence of a large amount of ammonia. But scientists still have to find out why lightning occurs mainly at Jupiter's North Pole. But did the probe really study only our formidable neighbor so closely? What did Juno manage to see in the immediate vicinity of the gas giant? The spacecraft successfully captured some of Jupiter's largest moons, Io, Europa, and Ganymede. The probe examined Io especially closely, approaching its surface to within 1,500 kilometers. This moon is famous for its incredible volcanic activity, which is most likely explained by its proximity to such a massive celestial body as Jupiter. In any case, Io is the most active moon in the entire solar system. Juno discovered huge lava lakes and also detected an equatorial volcano that had not been noticed by any probe before. The data that scientists relied on before has been clarified. Astronomers thought these were not lakes but lava flows, but the Juno spacecraft completely clarified the picture. Since Io is constantly geologically active, its surface changes over time, so future regional missions may see a somewhat different landscape. By the way, the probes flying past Io did not ignore the volcano at the satellite's equator. Most likely, it simply wasn't there at the time. It appeared. In the last 20 years, considering the size of the object, its width is about 177 kilometers. One can get an idea of the truly incredible activity of this celestial body. What other surface features on Io gain new interpretation after this probe studied the celestial body? First of all, it's the famous Loki Patera, a lava lake with a diameter of 200 kilometers, which shines like obsidian even from such a great distance. In the images, you can clearly see islands that apparently consist of the same material as the lake's liquid, but have solidified over time. According to the images from Voyager and Galileo, these land areas do not change over the years, remaining about the same diameter of around 3 kilometers. Their location is also unchanged, meaning these are stable, not floating structures. Do you remember what Wooland said? In Bulgakov's immortal work, The Master and Margarita, he reminded his companion that contrary to his wishes, the world is full of shadows, cast by trees, objects, buildings, and people. But some shadows don't just exist nominally. They have become part of the history of astronautics, like the shadow of Ganymede, which it regularly projects onto the surface of Jupiter. Before Juno arrived at this location, scientists knew about this phenomenon, but the probe managed to photograph it up close. What was the secret of Jupiter mentioned at the beginning of the video? It's time to reveal it. The secret concerns the planet's core, and Juno managed to completely change our understanding of it. At the moment, it is known that the core's mass is about 10 times that of Earth's, and its size is about 1.5 Earth diameters. But that's practically all we knew about Jupiter's most important structural part. In addition, astrophysicists believe that Jupiter's core, by analogy with other planets, was solid and stable, but it turned out that this was not the case at all. Since Jupiter emits a huge amount of energy, it's logical to assume that it generates it from within. What did Juno discover in this regard? It turned out that Jupiter's core is nothing like we imagined. It's very hot, diffuse, unstable, and much larger than scientists previously thought. It may make up half the size of the planet, which could indicate something important. Most likely several hundred million years ago, Jupiter experienced a catastrophic collision that destroyed the giant's internal structure, after which the celestial body literally had to piece itself back together. If the probe manages to measure Europa's ice shell, it will greatly help the future Europa Clipper mission, which launched on October 14, 2024. The start of the program itself is planned for the spring of 2030, since data from the Juno probe is still being actively deciphered by astronomers. What do you think awaits us ahead? What monsters are hiding in the inky darkness of the universe? Can we see these monsters? What could become a peephole in the giant gates of the macrocosm, through which we could at least glimpse 1% of the mysteries of the universe? The functions of such a portal have been taken on by the European Orbital Observatory Euclid with its onboard telescope. It was Euclid that, in record time, lifted the veil that for centuries prevented us from seeing what lies in the depths of our global world. The mission was launched in July 2023 from Cape Canaveral, after which Euclid headed to the Lagrange point, where it is now stationed. Almost immediately after beginning its work, the Space Observatory, named after the ancient Greek mathematician, presented images with astonishing clarity. And although Euclid's main goal is to search for dark matter and energy, to understand their nature and geometry, by observing the acceleration of the expansion of the universe, the telescope also saw millions of galaxies, including those located billions of light years away. What are the further ambitious plans for the Orbital Observatory? Its task is to create a grand cosmic atlas and a three-dimensional map covering a third of all the sky we can observe. This is a very labor-intensive mission, but if Euclid succeeds, it will be an unprecedented event in the history of space exploration. As a result, we will learn much more about how the mechanisms of the universe work than we know at the moment. The Euclid Orbital Observatory has presented a catalog that includes more than 380,000 galaxies and hundreds of gravitational lenses. It turns out that this is not an exclusive but a widespread phenomenon in the universe. What were the first images transmitted by the telescope like? These are images of several nebulae and galaxies that we know, but what's really impressive is that no Earth-based optics before this were able to produce such clear and detailed photographs. Moreover, no telescope has dared to look so deeply into the darkness of the dead vacuum as Euclid has. Truly, as they say, the way you name a yacht is the way it will sail. So, here is an exclusive top 5 of the first images sent by the telescope: the nebula, Horsehead, the dwarf galaxy, Barnard's new general catalog, 6822, the Perseus galaxy cluster, the globular cluster, new general catalog 6397, and the spiral galaxy index, catalog 342. You don't have to be an astronomer to see the obvious. Looking at these images, it feels like the galaxies were posing for the telescope in some kind of photo studio. The quality and incredible detail are mind-blowing. After Euclid sent these images, its potential and ability to create the largest 3D map of the universe in the history of space exploration became clear. This can be seen, for example, in the photo of the Horsehead Nebula, first discovered back in 1888 by William Fleming. It is noteworthy that it is gradually moving away from us and may eventually disappear from Earth's horizon altogether. This makes such photos especially valuable. So if you compare photographs of this object taken by Hubble and Euclid, the demonstration of progress in this field becomes most evident. Here are photos of the nebula taken with other telescopes, including Hubble. The difference is obvious. That's why, at the moment, almost all online publications and catalogs are replacing the old images with those sent by Euclid. We have no right to blame the website developers for this, because, for example, in the image of the Galaxy Index Catalog 342, without any interference from artificial intelligence or photo editors, the spiral arms are clearly visible, as if this object were in the place of our moon and not 11 million light years away. Why is the image so detailed? Previously, it was very difficult to observe the galaxy because it is located near the so-called galactic equator, or the imaginary system of celestial coordinates. What does this mean? There is a lot of dust in this location, which absorbs the radiation from objects, hence the difficulties in observations. But the Euclid Observatory, with the help of the next generation VIS camera and the Kinetz telescope equipped with a special design, was able to break through not only the layers of cosmic dust, but also through time. There is also a near-infrared spectrophotometer, and a spectrometer on board, which also contribute to higher quality images. The scientific significance of these discoveries is hard to overstate, since active star formation most often occurs in the region of nebulae. Ikonskaya Golova is no exception, and this means that we are now able to penetrate into the very essence of the universe, to get closer to the crucible where new stars are forged. What else has the Orbital Observatory become famous for? In May 2024, Euclid sent new images to Earth. Thanks to this, we were able to take a closer look at the Dorado Galaxy Group, the Spiral Galaxy, New General Catalog 6744, the clusters Able 2390 and Able 2764, as well as examine the star-forming region, Messier 78. The European Space Agency, with undisguised excitement, released these images, commenting that the photos from this telescope are a true triumph of science. They will allow scientists in the future to hunt for rogue planets and actively use lensed galaxies to study the matter of the universe, as well as to better understand the laws of evolution of our world. But even this is not the most interesting and amazing thing that happened in March 2025. It was during this period that the telescope observed deep fields of space and recorded 26 million galaxies, the most distant of which are located up to 10.5 billion light years away. Let's start by clarifying the terminology. What are deep fields? These are relatively small areas of the sky to which Euclid paid special attention, observing them for extended periods. As in the well-known meme, if you stare into the abyss for a long time, it begins to stare back at you. This method is perfect for looking into the very distant past of the universe, literally back to its very origins. Here are the visual results of what Euclid was able to see. Among the telescope's goals is not just mapping and generating images. The Orbital Observatory is also designed to measure the cosmological parameters of each object. However, the most important thing that scientists plan to find out, with the help of this space station, is to solve the mystery of the phenomena of dark matter and dark energy. These are the most mysterious components of the universe, about which we currently know only theoretically and very approximately. Meanwhile, it is these components that directly influence the fundamental principles of the evolution of the universe. What is dark energy and dark matter? Simply put, the main problem in studying these components, which are key in modern cosmology, is that they cannot be seen or measured in any way, since they neither emit nor reflect light. At the same time, they directly influence the evolution and structure of the universe. For example, dark matter. What is its essence and how did we find out that it exists? Dark matter reveals itself through gravitational influence, meaning it's what holds galaxies together thanks to gravity. So it's the foundation that holds everything together. What is dark energy then? It's an even more mysterious substance, supposedly causing the accelerated expansion of the universe. It's believed that about 68% of our macro world consists of it. Why does it contribute to expansion? The thing is, dark energy, hypothetically, has negative pressure, which leads to repulsion of molecules and consequently the expansion of space. So it turns out that dark energy and matter work in tandem, even though they have completely opposite properties. The first repels particles and contributes to the expansion of the universe, while the second, on the contrary, attracts them, which allows the formation of galaxy clusters and other megastructures. So the mission of the Euclid Observatory is precisely to study this issue more thoroughly. How will this happen? First of all, by measuring the redshift of galaxies and studying their characteristics. The gravitational lenses that have been found indirectly confirm the presence of dark matter in the universe, just like the microwave background. But most importantly, it's what we see with our own eyes. Galaxies really don't fall apart, and the stars on their outskirts move faster, which indicates the presence of additional mass that doesn't match visual observations. If there were no dark matter, the cosmic web, consisting of walls, filaments, and voids, would be impossible. Such structures require additional mass to explain their formation, as well as their stabilization within these shapes. That's exactly what Euclid is doing. Is there concrete evidence of the existence of dark matter provided by a space observatory? Yes, these are images of the Perseus and Abell 2390 galaxy clusters, with gravitational lensing effects, which in themselves are evidence of the mentioned fact. The Abell 2390 galaxy is located about 2.7 billion light-years away from us. A gravitational lens creates distorted shapes by bending space-time, which helps us see incredibly distant objects more clearly. But for this effect to occur in practice, the mass of the mentioned objects is not enough. Obviously, there is a huge amount of invisible and unaccounted for matter present. This is what we call dark matter. In the future, Euclid will create maps of dark matter distribution based on observations of millions of galaxies, and will determine the laws governing the existence of this invisible skeleton of the universe, which acts as the gravitational glue holding everything we see within structural boundaries. But did Euclid find evidence for the existence of dark energy? The Space Observatory is currently in the process of determining the redshift parameters of billions of galaxies, and the previously mentioned deep field method is especially helpful in this. This way, the telescope can peer into different periods of galaxy development, track their evolution, and understand how dark energy and dark matter influence their formation and essentially on the fabric of the universe. So, the interim results and the goal of the Euclid Space Observatory mission are quite clear, but what is the significance of its current and future discoveries for global science? First and foremost, it's about uncovering the nature of the universe, its laws, and the nuances of how it functions. Secondly, Euclid's discoveries will help improve our understanding of the structure of the macrocosm and the evolution of its objects. As for broader predictions, such research stimulates astronomical science to develop more actively, especially in terms of tools and technologies. And most importantly, it expands our knowledge of Euclid. Research into such phenomena will most likely lead not only to new discoveries, but also to a serious modification of existing cosmological theories. Therefore, the mission of the Euclid Space Observatory cannot be overstated. It is important by default. Our attentive viewers might ask, why spend astronomical amounts on launching an innovative project? If James Webb is already operating successfully and delighting us with new discoveries, is there a point? Since the tasks of these telescopes are different, James Webb is focused on studying smaller areas of the universe, while Euclid surveys much larger regions. You could say that the Space Observatory is a revolutionary phenomenon, comparable to the Gaia telescope, which gradually changed astronomers' understanding of the laws of our Milky Way galaxy. The solar system is gradually becoming quite a busy place. Humanity had barely recovered from the sudden intrusion of 3I Atlas when a new visitor appeared, 2025 V1 Borisov. But is it really a comet? A similar question arises when observing 3I Atlas telescopes. See it as a hazy sphere with no hint of a tail. Very strange, isn't it? Moreover, it behaves like an artificial object. Everything, from the incredible acceleration to the controlled exhaust like that of a shuttle, clearly suggests that we have a visitor from a more advanced civilization. Perhaps 2025 V1 Borisov is somehow connected to 3I Atlas. What exactly about the new visitor's behavior is making scientists uneasy? First, the object is moving at a very high speed. Second, although V1 is initially classified as a comet, it looks very much like something strange, almost as if it were artificially created. Gillerter detects abnormal gas emissions, including carbon monoxide and a huge amount of dust. Third, and this is the most important thing at the moment, V1 Borisov is the fourth potentially interstellar object to visit the solar system. You might ask, what's so surprising about this? After all, we're ordinary participants in the cosmic dance, and space routes pass through our star system as well. But throughout the entire history of astronomical observations, scientists have recorded only 4 interstellar objects, 2 of which appeared this year. We don't think it's a coincidence. By the way, doubts about the natural origin of both interstellar objects are not unique to us and everyone who has basic analytical skills. Professor of Natural Sciences at Harvard University astrophysicist Abraham Avi Loeb has been trying to draw the attention of the scientific community and the public to a number of oddities and anomalies associated with 3I Atlas and V1 ever since the appearance of the interstellar artifacts. However, scientists fight to the end, skillfully refuting almost every assumption made by Loeb. But there are some oddities that cannot be explained by anything. Have we finally encountered extraterrestrial intelligence? To begin with, let's recall what both objects are in terms of their physical characteristics. 3I Atlas is an interstellar visitor discovered on July 1, 2025 by a Chilean telescope, after which it was named. It is classified as a comet. But what if it's actually an alien visitor? The emissions of dust and gas, as well as the presence of a coma, definitely suggest something extraordinary. But why was it classified as an interstellar object? This happened thanks to its hyperbolic trajectory, which indicates that the huge, elongated boulder, several kilometers in diameter, came from the thick galactic disk. Some scientists believe that it could pose a threat to Earth. What can you say about Comet C 2025 V1 Borisov? The object was discovered on November 2, 2025 by the same amateur astronomer who discovered 2 I Borisovs in 2019. Whether this comet qualifies as an interstellar object is currently a subject of heated debate, since its trajectory is conditionally hyperbolic. However, it is quite possible that the visitor arrived from the Oort cloud, which is located in the solar system. If that's the case, then even though the comet came from far away, it is registered in the local region, so it cannot be considered interstellar. In general, scientists have not yet determined whether this comet has a tail. So far, a bright tail has not been observed, but astronomers expect it to appear when the object gets closer to the sun. What can be said about the approach of V1 and Earth? Unlike the previous object, the comet will approach us at a distance of less than 1 astronomical unit, meaning it will be closer than the sun. The approach will take place around November 25, 2025, and it is also considered absolutely safe for humanity. Some people try to classify the arguments of the mentioned Harvard professor, Avi Loeb, as speculation, attempts to attract attention, and to create hype around a popular topic. However, it's simply impossible to ignore many of the facts. For example, in his numerous interviews, as well as articles on the well-known online platform Medium, the astrophysicist highlights certain properties of these objects that force us to consider the technological hypothesis. Let's start with 3I Atlas. And its first peculiarity is non-gravitational acceleration. In simple terms, the object is moving too fast, and it's absolutely unclear what is causing it to accelerate like that. Usually, comets experience this kind of acceleration due to asymmetric gas and dust jets, which causes them to lose a significant amount of mass, up to 5 billion tons per month. But 3I Atlas, according to measurements from the James Webb Telescope, lost only 150 kilograms during the observation period, and that's 1,000 times less than what was expected at such a speed. In fact, to reach similar velocity parameters, you would need a gas cloud the size of our moon, but instruments do not observe any such structure. In short, Avi Loeb believes that there is a 40% chance this is an artificial object, and its acceleration can be explained by the presence of an engine. What is the second oddity of 3I Atlas that cannot be explained by traditional science? Why are not only Avi Loeb but also other astrophysicists starting to doubt that this is an ordinary comet and not an alien probe? Even though the object approached the Sun to within 600 million kilometers, it still doesn't have a clear tail. Why call it a comet? Is it a large snowball made of dirt and ice? That's why, as soon as such objects feel the warmth of a star, the evaporation process immediately starts and pushes out gases along with dust. That's exactly why we periodically observe spectacular sparkling tails millions of kilometers long. This is the standard behavior of 99.9% of all comets. So, what do we observe with 3I Atlas? Telescopes only identify a blurry glowing sphere without a visible tail. Isn't that strange? Maybe there's no tail because the object's surface is protected by some kind of shell that doesn't heat up. In other words, the visitor is actually artificial in nature, especially if you add the straight, non-dispersing jets that look like the controlled exhaust of a space shuttle, an unreasonably high level of carbon dioxide, to an unexplained composition with a predominance of nickel instead of iron, and also the fact that the object did not break apart. When it's at perihelion, like 90% of comets, the picture turns out to be quite unusual and even shocking. Could this comet-disguised Trojan horse be a greeting from another, more advanced civilization? What oddities did astrophysicist Avi Loeb notice while observing the flight of the new interstellar visitor C-2025 V1 Borisov? In this case, scientists are more reserved and place the object at the lowest level on the probability scale regarding technological origin. However, it's impossible not to notice the eccentric behavior of this comet. Again, among the oddities is the absence of a tail, which astronomers still hope to see later. It is noteworthy that the discovery of the object coincided with the appearance of 3I Atlas at perihelion, and this sparked a wave of new hypotheses. One of them suggests a connection between the two objects, as if hinting that V1 could be a reconnaissance probe launched from 3I Atlas. Despite the apparent absurdity of this assumption, the strange coincidence is hard to ignore, especially considering V1's closer contact with Earth later on. But what is the main argument indicating the artificial nature of 3I Atlas? Undoubtedly, it is the recorded radio signal coming from this object. In September 2025, several Earth observatories are conducting radio monitoring of the artifact that arrived to us from an unknown place and for an unknown purpose. By the way, Avi Loeb has been urging from the very beginning to closely scan the object, since its trajectory coincides with the direction of the famous WOW signal of 1977. And so on November 14, 2025, the observatories actually detected a narrowband signal at a frequency close to the hydrogen line, which is used by the network in the search for extraterrestrial intelligence and interstellar communication. Why is the signal narrowband? The thing is, broadband noise is usually only detected from stars. Why do we hear this sound? Since a radio signal can only be detected with highly sensitive equipment. Did you listen to the converted fragment, compiled from radio waves, temperature graphs, and precise calculations? Do National Aeronautics and Space Administration specialists agree to qualify this signal as evidence of the artificial origin of 3I Atlas? Absolutely not. They do not find any anomalies in the signal spectrum that would indicate its artificial origin or encoding. Therefore, the scientists of the well-known space agency stand by their opinion. Everything we observe is standard cometary chemistry. So who should we believe? Irrefutable evidence should come from high-resolution images taken by the Heresi camera, which is installed on board an orbiter flying around Mars. The photographs were taken on October 2, when the distance from the red planet to 3I Atlas decreased to millions of kilometers. In this case, according to calculations, these are the minimum possible values. Let's compare in the photo. Is it true that they are so narrowly directed and not fan-shaped like all comets with a precisely measured nucleus? In any case, we need to observe, not guess, as Avialoop suggests. And what if this is the notorious black swan? What is the meaning of this concept in the context of strange interstellar visitors appearing in the solar system? For centuries, it was believed that black swans did not exist, but in 1697, explorers discovered them in Australia. And this completely shattered centuries-old beliefs, changing biology as a science. Since then, black swan has become a term that means we are witnessing an extremely rare event with unexpected, far-reaching, and not always favorable consequences. Who knows? Maybe the arrival of 3I Atlas and the second Borisov comet will transform everything in our civilization, from the economy and politics to science and the lives of billions of people. Will the world never be the same again? At the moment, based on available scientific data and the opinion of National Aeronautics and Space Administration experts, the chances that the 3I Atlas object is artificial are extremely low. What are Harvard astrophysicist Loeb's opponents basing their arguments on? First of all, they point to the lack of maneuvering by this object and the natural origin of the radio signals. If images from the camera of the Mars orbiter show a fan-shaped coma on 3I Atlas, then the chances of the object being artificial will drop to almost zero. And yet, what will happen if it turns out to be an alien probe? What could its goals be? Most likely, reconnaissance supporters of the Loeb theory have been seriously discussing the landing of drone probes near Earth for observing human activity since the appearance of V1 Borisov. But what if it's a Trojan horse? Then perhaps the object poses a hidden threat and is maneuvering around Earth by indirect routes, disguising itself as a comet and planning a sudden attack. However, right now, no one knows anything for sure. So for now, all assumptions about a technological origin are pure speculation. At the moment, we observe that both objects do not actually pose any threat to Earth and are about to leave the boundaries of the solar system soon. You look at the sky and see an object rushing by at an abnormal speed. What would you think about it? Possible answers. A, it's a meteor. B, it's a satellite. C, it's an unidentified flying object. This video is intended for all categories of respondents because it presents evidence that cannot be ignored. Well, those who chose the third answer will have the privilege of being happy once again. What do you think about the stories of ghost rockets recorded in the Scandinavian sky in 1946, which did not match the activity of meteor showers at all, and the sighting of unidentified objects by the crew of Flight 105 over the Pacific Ocean in 1947, and the first video recording of a strange artifact flying over the city of Great Falls, documented by a local baseball coach? The history of observing unidentified aerial phenomena, UAPs or UFOs, goes back thousands of years, all the way to ancient Egypt and the Holy Roman Empire. But in the 20th century, with the advent of technology to record anomalies, the collection of unidentified flying object sightings increased significantly. However, most cases were explained either by natural phenomena, observation errors, or military activities. But there are 10% of incidents that cannot be explained even with thorough investigations. That's what we're going to talk about. So what is the Pentagon hiding from us, and why is it them specifically? It's noteworthy that those very unexplained cases, by a strange coincidence, are mostly recorded by the United States military or civilians. So the setting is the area around Mount Rainier. The time is June 1947. Who saw what in the American sky back then? Private pilot Kenneth Arnold, while flying near the mentioned mountain, suddenly saw 9 disc-shaped objects flying at an incredible speed for the mid-20th century. about 1,900 kilometers per hour. At that time, there was no aircraft capable of moving that fast. Kenneth Arnold called these objects saucers, skipping across the water, and since then the expression has taken on a fixed meaning. In common parlance, UFOs are still called flying saucers. As a law-abiding citizen, the pilot reported the incident to the United States Air Force military, and officials were never able to explain it, so the incident was included in Project Blue Book, where out of 12,000 cases, 701 never found a reasonable explanation. You know, a significant drawback in this story is considered to be the fact that the pilot didn't photograph the objects, even though he made numerous sketches. What do you know about the legendary Roswell incident? It's yet another piece of evidence of unidentified flying objects being discovered. Moreover, the most famous and controversial key event in the history of ufology took place in 1947 near the town of Roswell in New Mexico. This incident inspired the public to come up with the theory about Area 51, contributed to the creation of the X-Files series, and even led to the establishment of the International Unidentified Flying Object Museum in Roswell. So, what happened on that summer day? Farmer William Brazier discovered metallic debris on his ranch made of materials that looked like foil, but they wouldn't break or burn. When the man reported this to the local sheriff, who then informed the military whose base was nearby, the debris was confiscated a day later, apparently in haste. Officer Walter Hott of the military base stated in a press release that the United States Army had captured a flying disc. A couple of hours later, the statement was refuted by General Roger Ramey himself, but it was already impossible to stop the flow of information. According to official reports, these were the remains of a weather balloon. There were also theories mentioned in the West that they were intended to monitor nuclear tests conducted in the Union of Soviet Socialist Republics. But this situation still hasn't been fully explained. But that's in the past. And what about unidentified flying object detection now, considering the increased capabilities for recording incidents? The 21st century surprises unidentified flying object enthusiasts even more. And once again, in this context, United States Air Force pilots are often mentioned. For example, in 2022, something inexplicable was spotted on the cameras of an MQ-9 drone that was monitoring an object in the Middle East. Judge for yourself. What do you think this is? The stunned drone operator ignored his duties, and instead of monitoring the assigned object, started tracking this artifact that looked like a metallic sphere, flying at considerable speed and periodically disappearing from view due to the parallax effect. And this was filmed a year before the reported incident in the western part of the United States. How about that, Carl? What can you do? In the age of technological progress, it's hard to ignore the obvious facts. So, are we really sharing Earth's airspace with someone else? If everything I've said so far hasn't convinced you, then take a look at the footage shot from the American destroyer Russell. What do you think this strange, blinding triangle is? Skeptical scientists who studied the material concluded that it's the result of an optical effect, although even some Pentagon employees think the object looks more like a metallic airship. Do you want to see the clearest photo of an unidentified flying object ever taken during all the years of observations? Here it is. The flying saucer captured in New Jersey near the city of Passaic was photographed by George Stock on July 31, 1952. Unfortunately, skeptics at the time criticized the photo, calling it a lady's sun hat. Remember the famous Pentagon videos we mentioned in one of our previous videos? Now we'll show them to you again. And we'll also ask the question, why were materials recorded between 2004 and 2015 only made public now? Perhaps this is just the tip of the iceberg, and there is no point in hiding the accumulated facts anymore. In any case, Take a close look at these videos filmed from the aircraft carrier Theodore Roosevelt and draw your own conclusions. The objects you see themselves were called tic-tacs because they changed their trajectory and speed incredibly quickly. But no matter how many videos, photos, or incidents we examine, the question of who is operating in our skies remains open for now. Who did a group of civilians and scientists see through their binoculars in May 1949 when they just decided to go fishing? What was a 20-meter wide object doing at this location, hovering at an altitude of 1.5 kilometers above the ground? And if all this is just idle fiction and the result of an overactive imagination, then why? On July 26, 2023 hearings were held in the United States Congress dedicated to UFOs. So it turns out there was something to discuss? In particular, part of the event was dedicated specifically to Pentagon reports, some of the videos from which we have shown you. By the way, this is the first official hearing in Congress dedicated to such a controversial topic. They were organized by Congress members Nancy Mace and Tim Burchett. It seems this happened under public pressure and as a result of the unwillingness of United States Air Force officers to remain silent about what they saw while on duty. The central figure of the hearings was David Grush, an employee of the National Geospatial Intelligence Agency and a former Air Force officer. How did they testify? David Freevor, retired United States Navy Admiral, and Ryan Graves, military pilot? All of them personally witnessed the tic-tac and other incidents recorded during the exercises. For example, Grush claimed that at unidentified flying object crash sites, they often found biotechnology, in other words, alien remains, not to mention the wreckage of their vehicles. And Fravor described the tic-tac incident from 2004 in great detail. According to him, these were oval-shaped objects about 12 meters long, which had no visible engines, but they maneuvered with incredible acceleration, unattainable for modern technology. This was captured on video. What conclusions were drawn after extensive discussions in Congress? Tim Burchett stated, and almost all the speakers agreed with him, that the Pentagon has been hiding unidentified flying object data since 1947 and feeding the public convenient legends. In reality, both the Lubbock Lights, photographed by a freshman at Texas Technological Institute in the summer of 1951, and the unidentified flying object photos in McMinnville, Oregon, and objects resembling people with jetpacks, flying at implausible altitudes where even drones can't reach. All of this is neither a hoax nor a forgery, just like what 10,000 spectators saw at the football stadium in Florence in 1954 when they witnessed an entire fleet of UFOs suddenly stopping over the football field. The Washington incident, which took place from July 12 to 29, 1952, at the National Airport in Washington, also doesn't look like a fabrication. Here is one of the archival photos of an unidentified flying object from that period. Not to mention the world-famous Battle of Los Angeles, which almost coincided with the treacherous attack of the Imperial Japanese Navy on Pearl Harbor, during which, on the night of February 25, 1942, the Coastal Artillery of Los Angeles County fired anti-aircraft shells into the air for an entire hour at targets that later disappeared, or, as some contemporaries of those events say, it was a false alarm that happened against the backdrop of wartime hysteria. It gives the impression that right now something is at work pursuing unclear goals. Maybe these are people from the future observing their unsuspecting ancestors. Doesn't all of this remind you of some kind of simulation or a multi-component computer game on a universal scale? Pause for a second, look around and answer the question. Are you surrounded by reality or illusion? Take a closer look. Maybe it's not just the effect of tired eyes, but pixels are actually loading around you. Amazingly, even Pythagoras, Plato, and Aristotle believed that only ideas and numbers are material, and everything else is just illusory shadows. And with the development of digital technologies, these hypotheses are finding more and more confirmation. So, is it true that we live in a computer simulation? And how is this connected to Albert Einstein and Heisenberg's uncertainty principle? Before answering these and other questions, it is worth noting that if this statement is true, this discovery could surpass even Copernicus's heliocentric system in importance. What modern theories consider our reality as a simulation? What is the meaning of quantum uncertainty? And could life really turn out to be the Matrix? An active proponent of the simulation hypothesis is the Swedish philosopher, Oxford University professor, and director of the Future of Humanity Institute, Nick Bostrom. He is known for his arguments related to transhumanism, including cloning, cryonics, and uploading consciousness to digital media. One of the modern supporters of the Matrix hypothesis, Elon Musk, completely agrees with Bostrom. Moreover, he has repeatedly admitted that he would be happy if this turned out to be true. If you've seen the movie The Matrix, which came out in 1999, then you have a general idea of what this is about. And if you play Grand Theft Auto San Andreas or other games with realistic graphics, even more so. For example, the main character in the gameplay walks down the avenue, interacting with other characters, using weapons and vehicles. Meanwhile, on the parallel street, nothing happens, though the hero is certain life is bustling there too. This continues until the character appears in that location. Suddenly everything around comes to life and the place he just left turns into a digital void. This principle is at the core of any computer game, that is, in the digital world of shooters, strategies, and sandboxes. Just like in the Matrix hypothesis, reality depends entirely on the observer. But is there any scientific evidence for this theory? Or is it all just fantasy? You'll have to look for answers in the depths of quantum physics, a science so intricate that even experienced scientists get confused by its complexities. For this, let's turn to a well-known and most understandable example, demonstrated through the experiment of Thomas Young, first conducted in the early 19th century. Interestingly, this happened long before quantum mechanics emerged as a science and before the concept of wave-particle duality. What was the essence of the experiment? To put it simply, photons were passed through two slits, resulting in a diffraction pattern appearing on the wall, which characterizes the wave nature of light. This can be compared to tennis balls and ocean waves. The former passing through the slits will leave two clear stripes on the wall as expected from particles, while the latter will create alternating interference patterns from the spreading waves. It all seems logical. The wave nature of light is proven, but what's the catch? Here's the catch. As soon as detectors were placed near the slits, or observers were imagined, the photons immediately began to display particle-like characteristics. Similar experiments were conducted with electrons, neutrons, and protons, but the result remained the same. Obviously, all matter in the universe has both particle and wave nature, and its characteristics largely depend on the observer, just like in computer worlds. And here's a second clear example. Are you familiar with the phenomenon of quantum entanglement? Its meaning is that one electron is placed far from another, and in the absence of an outside observer, they are in superposition, meaning they simultaneously possess both key characteristics. But as soon as the first electron of the entangled pair, under the watchful eye of an observer, starts spinning, let's say to the right, the second one instantly begins spinning in the opposite direction. The same thing happens even if one electron is left on Earth and the other is placed on Neptune, or at the supposed point of the Big Bang singularity. It turns out that information between objects is transmitted instantaneously, that is, much faster than the speed of light. But can anything really move faster? This blatantly contradicts all currently known laws. Nevertheless, Albert Einstein didn't see anything strange about it. He believed that when an atom of any element emits two electrons, they already contain information about their future spins or rotations. But many years later, John Bell proved that the choice of electron characteristics is absolutely random and completely depends on the observer. What conclusions can we draw from this information in relation to the matrix hypothesis? They are quite obvious. In physical reality, many things seem impossible, but if you replace it with a computer simulation, then everything falls into place. The processor controls the behavior and characteristics of all pixels, no matter how far apart they are, and it doesn't need time for this. Everything happens instantly. What is this, if not a matrix? The computer simulation hypothesis successfully reconciles classical and quantum physics, avoiding paradoxes. Everything is logical, measured, and consistent. Moreover, the lack of specificity in the characteristics of electrons, that is, the presence of superposition, may be intentional, created to save resources, since even the most powerful computers have limited capacity. Of course, if you look at the history of cybernetics, it becomes clear how quickly our intelligent machines are improving. But considering the universal scale of the matrix, everything has its limits. Thus, the simplest possible option was chosen based on the observer effect. In other words, the calculation of the necessary characteristics, especially of small objects, is performed only at the moment when someone becomes interested in them. Compare this to the delayed rendering of minor details in computer games, when the overall concept is already clear, but the nuances are still loading. Humanity is already capable of creating virtual worlds that are strikingly similar to reality. And in the future, everything will become even more realistic. And who knows, maybe we will end up living in a simulation. Although perhaps right now, humanity is participating in someone else's project without even realizing it. Futurologist Medvedev, discussing Nick Bostrom's bold assumptions in his article, mentions terms related to the matrix hypothesis, such as the metaverse, which includes both real worlds and computer-generated ones. By the way, Bostrom himself allowed for not only simulation created by supercomputers, but also the kind demonstrated in the Matrix trilogy, namely artificial reality generated during sleep. What conclusions can be drawn after analyzing the information presented above? It's possible that right now, you and I are participating in a global virtual project, leveling up our skills every day, trying to farm as much loot as possible and get an achievement for completing a quest. But that's unthinkable, many will say, and they might be wrong. Think about it. A brain cell is also a physical object with certain characteristics, and as soon as we understand how it works, we'll literally be able to mass produce electronic versions of unique personalities and upload them to digital media. And these people will be able to live in copies of real cities. But has no one else tried to refute the observer's influence on objects? The most significant attempt to do this was made by Werner Karl Heisenberg in 1927. He claimed that an electron can change its wave nature to particle properties if it is affected by a photon of light. That is, it is this manipulation that can influence the electron and not the observer in any way. In addition, the scientists believe that you can only determine one characteristic of a particle, either its momentum or its location at a specific point, because it is impossible to measure both the coordinates and the speed of a particle with equal accuracy. This valuable discovery is called Heisenberg's uncertainty principle. It might seem that it could disprove the matrix hypothesis, but in fact, this principle does not contradict it at all. If we assume that there are many parallel universes, then each version will have its own parameters for quantum objects, relevant to specific observers, so everything fits together. It's unknown which of the stated theories is correct, but the idea that we are skillfully integrated into some kind of global virtual project keeps both modern researchers and ordinary people restless. Who knows? Maybe in just a few decades, against the backdrop of a new reality, traditional ideas about the world will look like Ptolemy's primitive map compared to a global positioning system navigator. Until these enlightened times come, earn experience points and level up your brain together with the Hubble channel. Who knows how wild and far from the truth our ideas about near space would be if it weren't for these tireless workers. So out of respect for their achievements, don't forget to like, subscribe, and share the video with your friends. There are still many new and equally interesting episodes ahead. Stay tuned.